So I've shown how simple it is, how easy it is to determine the actual weight of atoms complying with the data your scientist provided. So as I move along, you got the fifth shield, 5, 6, and 7. And after 7, everything becomes haywire. I know why, but I guess you don't. Of course you don't, because you're not a subscriber and you're not me. You are a scientist and you go by the books. And the books say there are 7 shields and they don't say why there isn't 8 and 9 or 10 shield. Well, they're your fucking books, not mine, so I don't care. It's books. So, numbers again. Weight complying almost exactly to the model. So my model complies in weight almost exactly. There's about 1% deviation, so they're 99% sure. 9% they have the right weight. Well, as I told you, in addition, where it is, there it is. In addition, I also managed to determine the number of protons per completed shield. And since I claim it's a gear system, you do that by using gears. Pretty simple. Again, of course, the universe is a simple mechanism. It's not that complicated as we are told by those super scientists, or should I say super idiots. Well, right here I have a simple thing. I have 4 gears, and when I turn one, you can see they all can spin. And that's actually what happens when you have, say here on top of hafnium, you have those 4, you have that spike with 4 legs, that pyramid. And those quarks are spinning. The other 2 quarks, you have 1 quark making up for the frame structure, the other 2 are spinning that structure, and you can see their spinning is perpendicular onto the frame, of course. So in case of a 4-part, those things can all spin and they can all become protons. There's enough space and they don't intervene. They can all become protons. Now, in case of a triangle, say a tripod, as here on curium, you can find on curium 1, 2, 3 legs, tripod. When you have a tripod and you want all of those, all 3 of them, to have a big circumference, because that's what protons have. They have a bigger circumference because there's an electron in an outer orbit. So they have a bigger circumference. Here is your triangle, and now you see it gets stuck. It cannot spin because they're all in each other's way. And the most efficient way is to just replace one with a smaller gear. Which means these can be protons unless this one sacrifices itself, remaining a neutron. That's my idea, gear system. I know it's stupid, but you're the scientist, I'm an idiot. But they spin around unless one of them backs down. They can all back down, but then again, if they all back down, you don't have as much energy. With diffusion, of course, energy wants to diffuse. Atoms want to absorb as much energy as possible, and the best way is to turn one of them into a neutron and the other 2 into protons. If they all back down a little, you know the laws of kinetic energy. If you apply those laws, when they all back down a little, you get less energy than if one sacrifices itself completely. So that's why nature chooses for 2 protons and 1 neutron in case of a triangle shape. And of course 4 in case of a pyramid with 4 legs. So you can have 4 protons here, only 2 in that configuration. There's another one. It's called a, you can see it right here. It's called a diamond shape. If you have a diamond shape, you have an elongated pyramid. It's elongated in one direction, tightened up in one, making these two hit each other. And then again, they get locked up unless one of them on the short side is a neutron, the other can be protons, or other configuration is this one. Both the outer legs, both the outer extremities are neutrons and the other two are protons. So that the two options in case of a diamond shape configuration of the legs. So, as I said, I'm using a simple gear system, and applying that gear system and applying these simple rules, this ended up having 6 carbon, ended having up 6 protons. Oxygen, 2 times 4 happened to have 8 protons. No. Argon, tripods, so one has to remain a neutron, you see? One neutron. And this one is a neutron. Why? Because this member makes part of this triangle, but also that triangle with the 2 ones inside. So if you sacrifice this one, all these 4 can remain spinning, which is the most efficient way to absorb as many energy as possible. Therefore, these are the neutrons and those are the protons. So that's argon, and you might think, well, hey, you're wrong with argon because that gives us in total of 1, 2, 3, 4, 16. But let me tell you, 16, yes, but they're also facing each other a little, so they don't have much valence. They don't have much potential to create a chemical bond. Argon is a precious gas, of course. It has problems creating a bond because the protons, all protons, are facing each other, sort of less facing each other. Well, that's the reason why argon is a precious gas. And you want something more? What about this one? We had 16 protons, but these are members of the solid structure, as shown in my earlier video. If you have a tripod or a four or whatever, one of them is gridlocked, makes up for the frame, for the structure of the atom, and that one is not spinning. So how does it have valence? Well, it does have valence because all adjacent nucleons are neutrons. They don't lash out the way protons do. Protons shield it off. When you look at oxygen, of course, these 8 are protons, but they lash out as well, covering, shielding off this thing. It has a little bit of chemical valence, if you will, but it doesn't spin, so it doesn't have much of it. It needs really something short of a miracle to make it bond, as an argon. But again, you see these are protons adjacent, shielding this one off. These are neutrons adjacent, don't shield it off. The same thing, again, for here, germanium, same thing, you have protons shielding off this thing, so this thing isn't part of, doesn't make part of that array of 2, 8, 18, 32, you know, that thing. Because I can say, well, those are protons, but that's not true, because in case of argon, only 16 are protons, but 2 others aren't shielded, therefore have some valence. So you get 16 having valence, some valence, because they are facing each other, and these 2 on top bottom also have a bit of valence since they're not shielded. A total of 18, but there are actually only 16 protons spinning. Now, if I move on, I use the same little Ouija board, the same little gearbox system. For all these things, I'm very consequent. You can check my videos, you can check my website, vedoder.eu, vedoder.eu. You will find that. You can find those things here on my internet too, on my website, and I'm very consequent. I don't fool you, I don't play any tricks with you. You're a scientist, I'm not going to fool you. You'll be on me, you can see through me very easy, so I'm not going to take a chance. Now, this is the same thing. We have here the fifth shield, and you have those four things, and you see those inside. Well, of course, they don't count, but if you count them together, again, you'll end up with the right number of protons in orbit, also for the sixth, but not for the seventh shield. The seventh shield has by your scientist a number of protons of 98, and I say the maximum number of spinning protons, the maximum number of electrons in orbit of the seventh shield is not 98, it's 102. Now, so there's this little discrepancy. You want to watch my, where it is, there it is. So I have these all right, and I have the number of protons right for every completed shield, which is close to a miracle. Of course, here whole numbers, so I have 0% deviation, only here is 4% deviation, 98 to 102. Well, I can explain that, but of course you won't believe me, but the thing is, why is it 98? Well, because your scientists say you take the number of the shield, which is 1 to 7, 1, 2, 3, 4, 5, 6, 7. You take that number, then you multiply it with itself, which means if you have shield 1, outcome is 1, if you have shield 2, outcome is 4, having shield 3, outcome is 9, etc. And then multiply it by 2. And if you use that formula, you will get, of course, 2, 8, 18, 32, 50, and so forth. So, your scientists say, well, there's a formula, it has to comply. Now we're going back to that China thing, back to that sweatshop, back to this big factory in outer space creating all those atoms for you. Come on, that doesn't exist. It's just simply compressing things. So, ask me, what is true? What is really smart to say? Well, there's a formula which accidentally they comply with, 6 numbers, only 6 shields comply, not the 7th one. And even if you include the 7th one, what about the 8th? But nobody's going to tell you the 8 doesn't exist. What if you take number of, n is 3, 4, 5, 6, 7, then it ends. What if you take n is 1000? And you take 1000 times 1000 makes 1 million. And the total number of protons times 2 makes 2 million. So if you have shield number 1000, you're going to get 2 million protons, 2 million electrons in your case, 2 million electrons in orbit. Isn't that totally ludicrous to think an atom can have so many shields? It is. But your formula, which says n is the square and then times 2 makes the number of electrons in orbit, doesn't have anything saying it stops there. Nothing. But my model not only says the number, it not only explains the number of protons meticulously, it also says why it stops after the 7th shield. And you are now free to accept either a formula which happens to be, which is wrong for the 2nd one, because actually those aren't in orbit. There's 16 protons, those electrons are, but those two, number 17 and 18, are not in orbit. They are solid, but sticking out. They are electrons though, make no mistake. And that's the funny part, you know. You say, you need a chemical bond, you need 2 electrons. Well, if indeed this one can bond, it means it's an electron. Meaning, every nucleon is made out of 6 electrons. There you go, which means 6 gravitons. So that complies exactly the number of protons and outer protons per shield complies again. So I have 99% sure, and of course this is, you can dispute this if you wish. You can still choose for your stupid formula or for my lifelike accurate models. Which one do you like to believe? I don't care. In the end, you'll end up with about 99% accuracy, both for the weight of my atoms and the number of protons, the number of electrons in orbit of the outer shield. So, what are the odds these are right? Well, 99% for one being right in general. The average deviation is 1%, so you get 99% accuracy. But 2 are right, then the 3, 4, 5, they're all right. You will get about 100%, if not 100% accuracy. If you make a model, a digital 3D model of this in your computer, a computer model, and then apply my rules, you're going to get those weights exactly right. So, what does this tell you about my model? You still not convinced? Well, in that case, let me take one of those atoms again. If you don't believe this is the real shape of an atom. Remember Heisenberg. Heisenberg had told about atoms of our electrons spinning around in local orbitals. Hello, local orbitals. Do you recognize local orbitals? And he said they disappear and then reappear on the other side in a pattern. Well, this is one big gear system. And if an electron is here in clear sight, in plain sight, because it's on the outside, when it's at the inside, you don't see it anymore. You think, hey, it's disappeared. No, it just was on the outside and then spinned around to the inside. And being a gear system, it does the same thing everywhere, creating a pattern. So why it's there, why it's spinning all around, it creates a pattern of electrons appearing and disappearing, just like Heisenberg. So it complies with Heisenberg's cat and Heisenberg's uncertainty. Now, isn't that cute? So that's another thing which this explains. But of course, you're not convinced now, are you? Are you not? But then look at the other thing, and that's the number of spectral lines. If you have an atom, and these angles vary, this is but those angles vary depending on the entire shape of the atom. And to give an example, I have here argon and its little brother, neon. Looks the same, but oxygen-based, carbon-based. Carbon, neon, the newcomer. I've counted those things. You can see, look, you see the angle, pretty shallow. You have this half, I call it half obscured. The oxygen thing is half obscured, and these ones are totally in plain sight. Now we're looking at, you see the difference? You see the difference? Look at neon. These angles are steeper. Steeper angles mean, of the carbon, the steeper angle of the pyramid means these are closing in, giving them half valence, and this one is totally out of reach. The weight of this comes down to, okay. You don't want to believe me? You want to see it for your own eyes. I have 9 times Diana. I have the third shield here. It's completed. The third shield, it's completed, the third shield. But this third shield is from another line, another array. You can find them on my attic, all those atoms. The number is 2 times 12. And then I'm going to subtract points for these one, 50%. Oh, fair. 1, 2, 3, 4, 5, 6. So I got a total of 18. No? Yes, 18. 1, 2, 3, 1, 2, 3, 1, 2, 3 is 9. Times 2 is 18. Minus 6 is 12. Those things in the middle, they're completely out of sight, but these are still half obscured. You get 12, and you got 6 half obscured, means 3, 12 and 3 makes 15. 15 plus 32% makes 20 use weight. What's the weight of neon? According to your scientists, according to those high-tech gods of you, 20 equals this neon thing. You want to flag down the number of protons, you just want to check that out? I use flags to do that, pieces of tape, right? You want to do that? I did that. You can do it if you wish. Guess what the outcome is? Guess what? 10, right, 10 is the outcome. So there's 10 protons in orbit, 10 electrons in orbit. Neon, 10 electrons in orbit, weight 20. Argon has how much? 18, actually 16, but okay, including these two, 18. Again, you exclude these ones because adjacent to it are the protons shielding it. So I think it's beautiful. This model is the atom model and the only accurate model on this planet to date. But you're still convinced, are you? So we can look at chemical properties. We want to look at chemical properties. Well, we had argon there. We got it's amazing that an atom I make has the right weight, the right number of electrons and carbon as neon and argon, and they look so alike, and they're both precious gases. You think that's coincidence? Come on! Oh, way in hell. You know this big sucker, completed shield? Well, it looks like a ball, doesn't it? Yeah, it looks like a ball, if not for those spikes. Well, if I deduct those spikes, what weight do I get? More importantly, how many electrons are in orbit? 80. And what element has 80 electrons in orbit? What? Can't hear you. Mercury, thank you, Mercury. And why is Mercury liquid at room temperature? Because it's indeed a ball. It's that simple. You get this one? Get off the spikes as well. What do you get? You get another ball, no? So what's that? I know. Liquid, I guess, no? Check it out on the internet. Check it out on your periodic table of elements. All elements before here, solid, 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 and then we get xenon, a gas. Accidentally the one without the spikes. So, coincidence? No. This thing is no coincidence at all. You want more proof? You want more proof? Count proof? Yeah, yeah. What's this? Ruthenium, ruthenium. This one is the one without the nucleons plugged in. So it has only number 44. Exactly. Completely symmetrical, number 44 on your periodic table of elements. Very sharp edges here. So it's strong metal. They won't move next to each other very easily. Then we got tin, which is almost buttery, because of course all holes are plugged. Guess what smacks in the middle? What smacks in the middle between tin and ruthenium? What's a bit malleable, but not as soft as tin? Silver, right, thank you. You will find this. Silver in between ruthenium, tin. Coincidence? Not at all. So now I have for you an atomic model, a model of atoms, completely in compliance with the data provided by your scientist, meaning this is how atoms exactly look like. But there's a problem there, because you call me an idiot, right? I'm the stupid man. I'm a fool. But I'm the only one capable on this planet to actually produce lifelike models of atoms. Did your CERN create these things? No, CERN is not capable of doing that. Up to now, they failed creating a simple thing as an atom. You think it's complicated? It's simple, it's nothing. It's a very simple chapter. Politics is even simple. Politics is simpler, but the rest is more difficult. You think quantum physics is difficult? Check out the other chapters of the entire blueprint. Oh my God, I can tell you, there are chapters there you wouldn't believe your head would blow apart if you read it. I'm not going to go there, I'm not going to discuss those things with you. I'm going to discuss, and I have discussed, only a very simple but striking part of it. I can discuss politics, but then there's always, well, it's not really an exact science, is it? This is exact science. You either believe it or you don't believe it. You either see it or you don't see it. If I can make a model, the only accurate model to date, most accurate model and the only model of atoms, this doesn't compare to Rutherford. Rutherford has electrons in free orbit. No way. It doesn't compare that. That's all. That's angels. Everybody knows that's angels. That's bullshit. So, CERN did it. They failed creating this. Fermilab, another big one. You look up to those guys? They're not capable of creating a simple thing as an atom model. NASA, not capable. Einstein, incapable. Sir Isaac Newton, incapable. Tesla, Higgs, your local university, yourself perhaps. Nobody on this planet has been able to present to you a simple thing as an atom model. That's a bit sad, isn't it? So, if that's 100% accurate, by your standards, not mine, your data, your science provided all that data, you've seen it, you've seen how I did it, you can repeat it after me if you want to. If you don't believe me what happens right here, just repeat it after me, look at my videos, it's 100% accurate. Don't take my word for it. Check it out for yourself, which is a very critical thing. And I'm the only one capable on the planet to make those things. And you think I am stupid. And I'm sure you think those people are very smart now, don't you? Right or wrong? Right or wrong? So the choice is, what side are you on, actually? Let me tell you something about human life. Let me tell you something about human life. Well, first things first. Let's go back to this checklist of being stupid. You know? That's what you're going to see how stupid I am and how smart you are and how smart our scientists are out there. Huh? That's it. I said a proton and an electron are physically connected. Well, I've proven it to you. I've shown it to you. If they weren't physically connected, this model would be shit. I'm telling you they're physically connected. The proton, this is a proton, and the electron is part of that. They are physically connected, they are one. That clear. You think it's stupid to think that after seeing all that evidence? You still think it's stupid to say a proton and a nucleon are connected? I know. Gravity isn't a field, it's an interaction between matter and particles. I've shown you these things spinning. Then I've shown you this, those individual gravitons hitting it, and I've proven without a question of a doubt, that those gravitons only interact with the nucleons spinning around in the outer shield. They only interact with the outer, not the inner. And if you have a field, it would penetrate it. No, it doesn't penetrate. So it's a particle, right? Particle interaction. Electrons and the nucleons interacting together, creating the force of gravity. So I say gravity isn't a field. I say it's by ether and Newton, of ether and gravitons. Ether, you get ether, there's gravitons in it, and they interact with the nucleons. So that's what I say, and you say that is stupid. No, I'm stupid, man, to think that. After seeing all that, you think it's stupid to suggest that? I don't know. Electron is a graviton. I will have go back to my star graph, read it. You can see how those quarks are created out of two gravitons. Why they pair up? Real thing. But you think it's stupid to say so. You think it's stupid to say a proton and a neutron has the same mass? You think it's stupid? They're the same object. Only one of them. Where the other one? I'm on a roll here now. Now I'm going to find the graviton. Right. Now we're going to find it. The thing between a neutron and there we are. Neutron. A proton is one of them sticking out. The number of gravitons, the number of electrons it is made of, is equal. Meaning the mass is equal, but when spinning around, this one is a little less efficient. So it gives us a difference, a small difference in weight, but the mass remains the same. Stupid to think so? Look at the model made out of these nucleons. So, but hey, you think that's stupid. Maybe you believe in Rutherford and his planetary model. Go ahead, I don't. And another thing, I say you can change the law of physics. You might disagree. You cannot change the law of physics. Shoot together. No, you can change the law of physics. Why? Because those laws are made by human beings. And human beings make mistakes. Many mistakes. I'm going to show you a few now. Just shortly, I will show you a few mistakes. A few very huge mistakes. Now, but you say you can't change the laws of physics. Think again. They're man-made. There are many laws I don't give a fuck about, and the laws of physics aren't any exception on that. So, mass cannot turn into energy and vice versa. I say mass and energy are two different things and they cannot turn into each other. Well, we have already seen that it's a simple mechanism. What do you expect? What are the odds I am wrong saying it's a mechanical interaction without mass or energy exchanging places? You think, well, that's not proven right here. No, Well, watch this. Einstein said mass can turn into energy and vice versa. If you look at a graviton and it interacts with these, do you recognize it as an electron? Do you recognize that bouncing graviton interacting with these atoms? Do you recognize that as an electron? No, because everything would be full of charge. But the reason it isn't full of charge because it's going at a normal speed. That graviton going at a normal speed. Only if you accelerate it, if you put energy in that electron, it will go faster. It has a more of an energy difference with those atoms. It has more of an energy with the spinning. Oh, where you go? There you go. If the graviton hits this at normal speed, no problem, because they spin normally. But if it goes very fast, you will recognize a spark or energy exchange or anything like that. So a graviton, an electron, you will not see an electron, you will not detect it when it goes at a normal rate, but you will detect it as an electron when it goes fast, and you will detect it as a positron when it goes slowly. So in that way, you can hide metal because it has mass. And when it goes normal speed, you don't see it. So you can hide it by making it go to normal speed. That's how mass can appear and disappear. Well, energy is the same thing. If you have one of those gravitons, it moves forward, it also has its own spin. Now, if that spin changes, its energy changes. And with a normal spin, you don't notice. It's the same thing. So energy and mass turning into each other? No way. It only looks like it, only appears so. But you can think I'm stupid for saying so. You can think I'm stupid for saying mass is not related to weight. Well, it's fine. Mass is not related to weight. There we go. You hear Einstein now? Energy and mass. Gravity is a curvature of space-time. We've just seen what gravity is. In detail. So is it the curvature of space-time or is it an interaction? It's a mechanical interaction. Thank you very much. Not a curvature. Einstein is a fucking idiot. He's a half-wit. No way. He is an half-wit. Don't tell me he's smart. Come on. He looks like a half-wit. He looks like a clown. He fooled, and that's, I grant it to him, he fooled mainstream science for over a century. Now that's, well, I think it's admirable. Being an idiot or not, I think that's admirable. He's a very sloppy guy. You can see it in his eyes. He's a sloppy guy. He isn't very precise at all. So he makes mistakes like this, without a doubt. Newton, that's where we were. Newton, I told you. Mass and weight are not related. Now weight is the force, of course, so get F is mass times a constant. That's Newton's work. The constant being G. And, well, I can agree with Newton, they are related. If G is indeed a constant. But G on Earth is different than G on the moon, or in between, or on the sun, or Mars, or even on the surface of the Earth, G changes. And I'm not talking about centripetal forces. G isn't a constant. G is a variable. So yeah, everything is connected when you use a variable. We can see that there's graphs of mine. I've seen it. This graph. You see the red? That's the total number of nucleons of all those elements I've shown. All those elements I've lined up here. From helium, oxygen, argon, germanium, tin, hafnium, and curium. There they are. The red one is the total number of nucleons. And the purple one is the weight. And as you can see, the mass, the total number, makes up for the mass, makes up for the inertia. The total number does not relate to the weight at all. It's not half, it's here it's half, but not here, it's about 3 times as much. So there is sort of a relationship, sort of, being roughly, but in detail, no way, they're not connected. You can see right here, you get the purple one, this is beautiful. Check this out, the purple one is reality, according to you. The blue one is reality, according to me, which is almost the same. Funny, isn't it? No, its mass and weight are not related at all. It only looks like that because every atom has about half nucleons, about half protons, and they're all spinning around, all contribute, and therefore it looks like it is related, but it's not related because, well, G isn't a constant, that's one, and the other thing is, mass is the number of particles a thing is made of. It's the inertia of the thing that's mass, and the spin of it, and the spinning of the nucleon on it, that provides the weight. So Again, do you think it's stupid of me? Do you think it's stupid of me to say that weight and weight and mass are not related? Is that stupid of me? Yeah, think so. Do you think it's stupid for me to suggest that star drive obliterates space-time? Do you think it's stupid? You know, Einstein was a clerk in a patent office. He didn't write his space-time. He based it on works of others. Yeah. So, especially Lorentz, and the things he added and dismissed. He dismissed Lorentz ether. Lorentz said there's an ether. He dismissed that. That's stupid because there is an ether. I've shown you there's an ether, and Einstein dismissed it. And he's a scientist in your eyes. You look up to him. You think he's smart. You think that you're smart by sucking Einstein's dick. Come on. Beating CERN and Nats to the punch. I've obliterated star drive, no problem. Beating Einstein and beating CERN and Nats to the punch. I beat them to the punch. Yes, I did. And I will continue to do so. I will beat. I have beaten them. And I will continue to do so. I will not only disclose the works of atoms. No, I will tell you how everything works. Life, death, the whole thing. I'm working on the entire model. Well, ask NASA about life and death, please do so. They probably laugh. It's not that specialization. Well, specialization means also being restricted. And I don't restrict myself. I want the entire picture. Not just this little part, not just this stupid thing you call quantum physics. It's amazingly simple. But hey, the list. I'm stupid for thinking my proton and electron is the same. How stupid am I? I'm a stupid idiot. I know, I can be an asshole, but hey, not when it comes to science. That's my modest conclusion. Maybe you conclude otherwise. Maybe you think I'm cheating here. I'm a magician or fucking around with your head. I'm not fucking around. These are the only experiments today, which makes Vido.eu the leading scientific institute on the planet today. Not CERN, not Fermilab, not NASA. Vido.eu is the leading scientific institute. A one-man operation with a zero budget, beating all those you look up to. That's fine, isn't it? But you still think I'm stupid, don't you? Well, I'm out of paper, I guess. That's enough to tell you. Oh well, there is. You know, remember the thing I told you about religion? You remember that in the beginning? The video prior to this one, I told you about, I think you are religious. Well, I've shown you the evidence, clean-cut evidence of how the universe works and how atoms are made, how they're created and how they look like in real life. There's no way about it. You've seen the accuracy of it. So that's proof. And you might think religious people are stupid for holding on to their beliefs without being afraid to switch, being afraid to accept the evidence provided by scientists. Well, I say, unless you agree with me, and if you think I'm still stupid, if you still think this is bullshit, then you're the one afraid of letting go of your beliefs. Then you're the religious person, believing in your gods like Einstein and Newton, your churches like CERN and Fermilab. You're afraid to let go of your beliefs, despite the evidence provided by science. That's what most scientists blame religious people for not accepting the reality. Are you ready to accept reality? Or do you think, no, I'm still fucking around here in your head? It's true. Make them, build them, repeat after me. No, it's very simple, you will see it. And even, maybe I make mistakes, you can find those mistakes. And maybe you can expand this model, make it can help me instead of being my enemy. I need help, I need all the help I can get. But hey, you want to stick around with your old beliefs about Rutherford and Einstein? What space-time? Want to grab on? What evidence shows you different? That makes you religious. So that's the choice. You're either religious or you're not. And when you're not religious, why not accept it? Fear. Fear, that's a good one. You're afraid. If you think you're not afraid, you are afraid. I do. You must be afraid. You know, the body is the boss over our mind, and the body uses fear to control us. In fact, if you have estrogen and testosterone, those are two, they shape our characters a little. Women are driven by fear to handpick the best food, the cleanest food, and the cleanest environment for their children. And some are so afraid, their estrogen levels are so high, they are making them so afraid, they starve themselves to death being afraid eating the wrong thing. It doesn't matter whether they're pregnant or not. No, they think if I eat the wrong thing, my child will die, either inside my belly or when I feed it, or when it's eating from my chest. The kid will die. That's fear. And even if they're only 12-year-old without being pregnant, their estrogen levels are that high, makes them afraid. On top of it, they'll sort of those pills, anti-conception pills, which also contain estrogen, making the fear levels shoot up even to the top. They don't have a boyfriend, maybe they're a bit to themselves. They don't hug, they don't kiss, they don't swallow, so they don't get any testosterone to compensate for their estrogen levels. Because that's what oral sex is all about. It's about compensating and adjusting your testosterone levels. I haven't touched a woman in 18 years. Means my testosterone levels are out of the roof. Means I'm very afraid. I need and I must control my environment, because that's the male side, where women try to figure out the best food for their kids. We are trying to control the environment so she can raise kids. We want our environment controlled. And one big thing in that is knowledge. If you have knowledge about your environment, then you're in control of your environment. And that's why I say maybe you're afraid. Because you have an idea of how the world works. I show you different. And maybe you're afraid to let that go and hold on to the other thing. Because then you wouldn't be on top anymore. But don't be afraid. I'm more afraid than you are. I told you, my testosterone is out there. I'm really afraid. That's what brought me so far. That's why I can do those things. I'm dedicated to the job. I have my views, I have my goals, and I will reach all of them, including eternal life. Including eternal life, no problem. I will heal all diseases. Doesn't matter at all. My profession is I'm a designer profession. I've designed all kinds of things, from electric circuits to mechanics to buildings. It doesn't matter. It doesn't matter whether I make those things, whether I design those things, or I design the universe or your DNA. I don't care. It's the same thing to me. So that's what I do, and my fear levels push me out to the top. And yeah. So, well, you can dislike me or not, but bottom line is, am I stupid? Well, that's what we're after, right? Am I stupid? Are you religious? Am I stupid? Come on, you know better than that. You know better than that. Check out Heavens again if you don't agree. Okay, well that concludes our lessons. Don't call people stupid on the internet, because you don't know who's on the other side. Thank you. Bye.